Well, hello, welcome back to Machine and Materials Safety. We've been talking about cranes and net capacity calculations. We've done several net capacity calculation problems in class, and you've had some practice problems, but I want to give you one more variation, a different type of configuration that you may encounter. Let me just run through this very quickly, or as quickly as possible without moving too fast. Remember, when we do a net capacity problem, we start by writing out the formula. NC equals GC minus deductions. Again, I like to abbreviate everything to save time. If you're taking a certification exam, which this is the type of thing that can show up on a certification exam, you want to move quickly so you don't run out of time. That's the reason for the abbreviations. Okay, we write out our formula. Then we draw out the crane configuration with a diagonal line representing the length of the main boom and a horizontal line representing the length of the radius. The main boom length in our data table is 130 feet. Go ahead and label that. Our radius is 70 feet. Go ahead and label that. Again, I am moving fast because we've done this several times, but let me know once you get a chance to see this. Let me know if you have any questions, if I move too fast, if something was confusing. Okay, now we want to draw in the rest of our configuration. We have a jib that's 30 feet long. Remember, a jib is just an extension of the main boom that's attached to the main boom. Go ahead and draw that in, and it's 30 feet long, and it's set up at a 15-degree offset. The offset is the angle of the jib to the main boom, and it's 15 degrees. This configuration, we also have a load block with 4 parts of line. The block weighs 4,815 pounds. And remember what we're doing here, we're writing in the deductions for each of these components. We're creating a column of deductions that will add up once we get everything written in. We got our block. There's 4 parts of line. You don't have to draw in all 4 parts. I just use a number like 4x to remind me that I've got 4 parts of line. And we will need to calculate the weight of those 4 parts of line, but we'll save that until later because we're going to have to go into the load charts, the document itself, to look up some information before we can calculate the weight of the line. Going back to our data table, we have a ball that weighs 860 pounds. And we have 10 feet of wire rope that's connected to the ball, 10 feet hanging off of the jib. And that's going to be a deduction. It's going to be a small number, but we still have to account for it. So we have 10 feet, and there's only 1 part of wire rope, so it's going to be 10 times 1. And each foot of that wire rope weighs 2 pounds. So it's going to be 10 times 1 times 2, or 20 pounds is the deduction weight for that wire rope. We have 600 pounds of rigging. And I like to use an open triangle to represent my rigging in my diagram. And again, the rigging weighs 600 pounds. Go ahead and label it so you keep track of what is what and where is what and so on. But we got 600 pound deduction for the rigging. There are still 2 items that we need to deduct. We need to deduct the weight of the jib. And to find the weight of the jib, I save that until later because we have to look that up in the crane documents. Zoom it up a little bit here so we can see better. All right, there's a table in the crane documents that has the effective weights for all of the different jib lengths. Our jib is the 30-footer, so there it is right on top, 30-foot jib, the effective weight 2,700 pounds. So we'll write 2,700 in for our deduction. And now we need to find the weight of the wire rope that's being used to make the lift. And I said previously, before we can do that, we would need information from the chart. So we find the specific chart for 130 feet for a 130 foot long boom, or 130 foot of boom. And there's that chart. Now we find the radius that we're working at, which is 70 feet. The far left-hand column of the chart is the operating radius. We go down this column until we get to 70 feet. And there is the information that we will use associated with a 70-foot radius and a 130-foot boom. The third column from the left, boom point elevation in feet, 120.7, 121 feet when we round up, when we round to the nearest whole number. Now, to calculate the weight of this wire rope, we're using a method called the tip to ground method. And when you're using the tip to ground method, you're using the distance from the tip of the boom all the way to the ground. And that's what we've got here with the boom point elevation in feet, is 120.7 or 121 feet. So we write in our 121 feet. We're going to multiply that times 4 because there's 4 parts of line, 4 sections of line. And then we're going to multiply that times 2 pounds per foot, which we get from our data table. When we multiply that out, 121 times 4 times 2 equals 968. That is the deduction weight for the wire rope that's being used to pick up the load. But I'm going to double check that to make sure I didn't enter a number incorrectly. Yep, 968 is the number we need. Again, the reason to double check your math, I won't do that every time, but the reason to double check your math is because of the nature of what we're doing. If we miscalculate something, it could cause a crane accident that could crash a $3 million crane, or it could cause a crane accident that could hurt or kill somebody. That's why you got to be real careful with your numbers when you're talking about heavy industrial operations. You got to be dead on with your numbers. Double check, recheck. Make sure that you are doing it correctly, because the consequences are just too great if you make a mistake. All right, it looks like we have all of our deductions. Let me go back through real quickly here. We've got our deduction weight for the jib. We've got our deduction weight for the block, 4815. We've got the weight of the wire rope accounted for. We've got the rigging, 600. And we've got the headache ball, 860. And we've got 20 pounds deducted for the 10 feet of wire rope. So that's everything. We're ready to total our deductions. Bring our calculator back up, starting at the top of our column, 2,700. Pull this over here a little bit. 2,700 plus 20 plus 860 plus 968 plus 4815 plus 600. 9963, and I'm going to double check that just like I double checked the other one, our other calculation previously. Go ahead and store that for now. 2,700 plus Yep, 9963, we're good. Go ahead and record this. $9,963. Get my comma the right place there. And that's the total deductions that we're going to plug into our formula. And I'm going to go ahead and do that. All right, we're about halfway there. Now we need our gross capacity. And as you know from previous classes, gross capacity is going to be the lesser of the chart capacity or the line capacity. Let's go ahead and find our chart capacity since we have the chart up on the screen already. And I like to write everything down. Writing things down, recording what you're doing helps prevent mistakes. So write down our chart capacity, and our chart capacity is going to be either 60,600 or 70,900. How do we know which one to use? Well, we have two columns. We have a column for capacity with the crawlers retracted. Then we have capacity for crawlers extended. We go back up to our data table. Crawlers are extended, so we'll use the right-hand column, 70,900 pounds, as our chart capacity. 70,900. Now we need to find the line capacity. Again, I've seen a lot of people make this mistake over the years. They get the chart capacity, they'll plug that in for their gross capacity. But the chart capacity is not necessarily going to be the gross capacity. It's going to be the lower or the lesser of chart or line capacity. Our line capacity is the strength of the hoist lines that we're using to lift the load. If our hoist line strength is less than our chart capacity, then the hoist line strength is going to be our gross capacity that we use in the formula. But we need to find the line capacity. We have 4 parts line. So every part has a strength rating. We need to find that strength rating. That is in the load chart document right here. Maximum capacity, wire rope, 29,500 pounds. That's for one part. We've got 4 parts, so we need to multiply 4 times 29,500. And I believe that's 118,000 pounds, but let's do the math just to make sure. 4 times 29,500 equals 118,000. So we have chart capacity and line capacity. Gross capacity is the lesser of these two. The lesser of these two is chart capacity, 70,900. Now we're ready to find our net capacity, finally. Gross capacity minus deduction, 70,900 minus 9,963. $60,937 is our net capacity. And net capacity is how much we can safely lift with the crane when the crane is configured with 130 feet of boom at a 70-foot radius. If we go above, if our load weighs more than 60,937, there's a chance that we could have an accident. The crane could collapse or the crane could tip over. So to be safe, we have to make sure that our load is less than our net capacity. All right. Quick review. You guys have been doing a good job with these, but I wanted to give you one more variation. Let me know if you have any questions, and I will see you in class.